This lesson is for FST, Lesson 2-2 on linear models. 2.2 and 2.3 actually kind of go together. So this lesson and the lesson for 2.3 will coincide with each other. They're both about linear models, and one of the things we'll do is help students figure out which model to use. The slope-intercept model is the one that they're probably most comfortable with because that's the one they've used the most in Algebra 1 and Algebra 2. But the one that I'm going to point students towards more is the point-slope model. And that model is y minus y1 equals m times x minus x1. What's beneficial about the point-slope model is that once you have a slope and a coordinate picked, you just fill in those values and you're done. Your model's finished. Tomorrow, when we look at Lesson 2.3, we're going to learn how to find a linear model by hand and on the calculator using linear regression. So those pieces will be coming. Know that today we're going to head in a little bit of a different direction with linear models. Our goal is to calculate residuals to determine which line is the best fit line. So today we're going to work with two models that have already been determined, and then we're going to compare the sum of the squared residuals in order to determine which line or which model is the better model. So we're not going to get into how to find a model today, we're going to do that tomorrow. Today we're just going to figure out which model is better by utilizing some of this vocabulary to calculate the sum of the squared residuals. Some of the vocab that you're going to work with in the lesson involves interpolation and extrapolation. Interpolation is just a prediction between known values. Extrapolation is a prediction beyond known values. We're going to work with some data today, and I want to just quickly point out the difference between those two as it relates to the data. So here's the data that we're going to be working with. It's from page 89 in the textbook. And interpolation would be you using a model with a value that's within the span that's given. So for example, 0.17 is not here in the table, but it's within some values that I already know. So if I plugged in 0.17 for x into my model, the answer that I get would be considered an interpolation. If I grabbed a number like 0.5, 0.5 is beyond any of these values, so that would be considered an extrapolation. So if I plugged in 0.5 and I got an answer, that number is beyond anything that's here in the table. So that's those first two vocab words. The three that we're going to focus on today are observed, predicted, and residual. An observed value is simply the original y values. So when we're working with our table today, the first column are the x values, the second column is the y. So these are going to be called our observed values. And I've indicated that down here for a worksheet for the students to kind of fill in as they go. So the original data here is the x, and the original y value data here is going to be labeled from now on as the observed data. Going along with that, we have the predicted values. The predicted values are the new y values after we've generated them with the model. So what we're going to do today is generate the predicted values for y with our models. And we have two models we're going to work with. Again, today our focus is not to determine where those models came from, but simply to evaluate them and compare them to each other. So we'll have the calculator plug in all the x values into the two models, and it'll generate some predicted values for us, and we'll fill in some of those here. Then our next calculation is to simply subtract those two pieces from each other. If you subtract them, you get something called a residual. The residual is the star of the lesson. He's the main focus. Once we get the residuals, we're going to square them and add them up, and the smaller of the two values that we come up with is going to be considered the best fit line. So that's where we're headed today. We're going to be finding those residuals. Let's look at it in a little bit more of a visual fashion here. Again, if we have our data and we graph it in a scatter plot, we see these red dots here. Those are all my data. And so they could potentially form a straight line or a linear situation. So we're going to utilize this first equation of 2400x plus 400 to see if that is an accurate model for the data. And that model has been graphed here in this picture. And I guess I would say that it's not really the greatest best fit line because it's missing quite a few of the data points. To me, the data kind of goes this way, and my line is kind of sloped or slanted, not quite as steeply as it needs to be. So what we would do today is graph that line, graph our points, and then we would find how far apart the data and the lines are from each other. So if you look here, a residual will measure this data point's distance away from the line. Same thing here, we'd measure this distance away from the line, the distance here, the distance there. This one's almost right on the line, so there's probably not much of a distance there to measure. Here we've got a slight distance and then a distance here. So our job today is to find those lengths, square them, and add them up. So there's two options that I'm going to show students in this video for how to get those residuals. So I need students to go to their calculator and start up a new spreadsheet page. You'll type in all of the data in columns A and B. So pause the video and go ahead and accomplish that. Once you're done, make sure that column A is labeled with the letter X and column B is labeled with the letter Y. After the data is in there and it's been labeled with X and Y, do Control-I to get a new tab and choose Data and Statistics. And when you do that, you're going to come up with a blank graph like this. At the bottom, it asks you to click to add a variable. So use your touchpad to go ahead and click down there and choose X. You'll find that all the data kind of lines up. Click over here now on the Y-axis and choose Y. It should graph all of your data for you. So there's our scatter plot once again. We're going to go ahead and get the calculator to plot our model for us right on top of it. To get that, you do Menu, Analyze, Plot Function. It'll allow you to type in your equation, 2400x plus 400. And it'll graph the line for you. Again, we would say that that line isn't that great because it's missing out on what we really need for the slope, which is a much steeper slope. So then we need the calculator to generate the distance from each coordinate to the line. And to get it to do that, we go back to Menu, Analyze, and then we choose Residuals. The only option when we do residuals is to show residual plot. Go ahead and choose that. And so here you'll have to hover over each point to get what the value of the residual is. So in this first coordinate goes with 0.15, the first data point, and the residual there is negative 275.5. So let's go ahead and write that down. So for our first x value of 0.15, we got negative 275.5. Let's go back and read a couple more of those. The next data point is for 0.16, and the residual there is negative 277. And let's do one more. The next one is negative 130. So we've got three of our residual plots there, negative 275.5, negative 277, and negative 130. So let's just peek back at those one more time on the graph here. Negative 275, negative 277, and negative 130. So there's other coordinates there that we would need to copy down as well. For now, I want to just save time and say, hopefully you've got the idea. So that's one way to get the residuals. Then you would need to square those and then add them up. And so there's another option for kids that I want to show you, and that's utilizing your spreadsheet a little bit more in detail. So let's go back to our calculator. So let's go back to the calculator and let's maneuver back to our spreadsheet page. So to do that, do Control and then the right or the left arrow. So I'm going to go back to the list here. So all my data is there. The next thing I want to do is have the calculator give me my predicted values. So I'm going to type in the model into this diamond row here. So I'm going to type in my model. As soon as you tap in that cell, it should give you an equal sign. That tells the calculator to go ahead and do the calculations. So you want that equal sign to be there. So we're going to type in our first model. You could use X here. I'd recommend using A because that's where the X's are located, and I found that the location works better than the variable name. So I would encourage you to use A here. X should work, but I found that it's easier to use the location instead. So we type in the model, and it gives us our predicted values. So let's write down a few of those. 760, 784, 832. And let's label what we're doing as we go just to kind of help students track with all the different values here. The x's were in column A, the observed values or the y values were in column B. In column C we typed in our model and we got our predicted values. And now to get the residuals in column D, remember that what a residual is the observed minus the predicted. So if we just do B minus C here, we'll go ahead and get those values. So let's go ahead and type in B minus C here and we'll get our residuals. B minus C, and we have our residuals. Next thing we want to do is square those. We want those values to be squared and they're in column D, so we just say D squared next. And we will take all of these values and square them. The last thing I want to do is get all of those to be added up. So I need to highlight by arrowing all the way up until all of column E is highlighted. To get the sum, I do Menu, Statistics, Stat Calculations. Let's try that again. And choose one variable statistics. You'll get two pop-up windows, just say OK on those. And the second one down is the one that you're looking for. The sum of the x's is 237,779. So let's go ahead and write that down. The sum of the x's was 237,779. And let's go back and write down what we did here for our columns as well. In column E, we had done D squared. And in column F, we did one variable statistics. Now that number that we got is not a very interesting number as it is right now. What we would need to do next is change the model to our second option. And if we just type in that new model, it'll automatically recalculate all of these values for us, and we'll be able to look at the sum for model number 2. So let's go ahead and get that model typed in into column C. So let's go back to that, arrow over, and we're just going to eliminate that equation. If the equal sign goes away, just bring it back, and we're just going to type in model number 2. I'm going to go ahead and type that in here. Just going to pause the video to do that. So when you type in your model here, just a reminder to use A instead of X. You'll get a pop-up window that says, do you want to overwrite the data? And you should say yes. All the data has now been changed. The number that we're looking for is the sum. The sum is of the new model, 55338. So let's write that down. And so now our goal is to look at the two values we got, the two sums, and determine which one is the better model. The one that is smaller is the better model. And that's what we're trying to get to today. Calculate the sum of the squared residuals, and the one with the smallest value is the best fit line. So as you compare the two numbers, the smaller one is this one. So the model that better fits the data is model number 2. Students have questions or need a repeat on what we did for the calculator, they're more than welcome to ask me during class or to rewatch the video. Good luck.